Hey 30-2s, welcome to your final lesson in polynomial functions. This one's all about applications. This will be a short video. Well, we've been looking at applications this entire unit, but what I really want to focus on here is not about finding numbers, not about finding our normal kind of answers like we've been doing with regressions. What I want to focus on here is simply where am I going to look on the graph to find answers. So I'll show you what I mean. Let's look at this scenario here. So this one is about a rock being thrown off a bridge, and I always want to know what my variables are. So t is time in seconds, h is height above water, right there. Okay, so what we could always do is we could go and graph this. Now, I've already done that for you. I'll show you. It's right there. That's what you would see if you punch that into your calculator. It's a nice downward facing parabola. Okay, let's go answer some questions. The last couple of questions on our diploma will be polynomials and sinusoidals, your next unit. And they're not, again, about finding numbers always. Sometimes it's just about where do I look. So I'll show you. A, the height of a bridge from which the rock is thrown. Well, if I look at the graph, if this is time on my x-axis here, and this is height here, where was I thrown from, or where was the rock thrown from? I hope I wasn't thrown. It's right there. That's the y-intercept. How do I find it? Well, I can simply let x equals 0, or I could look at my constant term. And so in this case, 8 meters. Now, again, sometimes it's not going to be about the answer. It's going to be where am I looking, the y-intercept. Okay, the maximum height of the rock. So I go to my graph and I say, yeah, there's my max height right there. So I'll have a lot of students say the answer is the vertex. But I need you to remember the vertex is made up of an x and y coordinate, or in this case, a t and h coordinate. So where am I going to look here? I'm going to look at the h coordinate of the vertex. How do I find that? Well, on a TI, you would go second, calc, max. And on this question, it's at 9 meters. But again, the more important part is the characteristic there. Time at which the rock hits the water. Okay, well, the rock hits the water right there. So I'm going to call that my t-intercept. But I need to be careful because there are two t-intercepts. So how do I tell which one I'm talking about? I'm going to say the positive t-intercept, just like that. Okay, and that was at 4 seconds. Now, the other way to find this, which I prefer to do actually on a TI, is to let y2 equals 0 and find the intersection. D, time at which the rock is 7 meters above the water. Okay, well, 7 meters is right here, so it's right there, 7 meters. So how am I going to find that? I'm going to find the intersection. And I'm going to let y2 equal 7. And that looked like it was at about approximately 2.5 seconds. Okay, of course, if this was a test, I would actually do it in my calculator. Now, again, a lot of these questions aren't going to be about the answer. They're going to be about the characteristic. Couple more for us. Very, 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 very common questions for diplomas. What are the restrictions on the domain, the range, and then we'll talk about G. Well, what do I mean by that? Well, if I come and look at our graph here, if I just put this into my calculator, this is the parabola I'm going to see. But my domain is not the real numbers because this is an application question. So really, when I'm thinking about this question, I should solely be focused on quadrant 1, because that's where time is positive and it's where my height of my rock is above the water. So what's my domain then? Well, time has to be bigger or equal to 0, and time stops at 4 seconds when I hit the water. So what are the restrictions on the domain? Well, what I'm going to say is my characteristic here. Well, really, friends, I want to say I'm really looking in quadrant 1, right? And I need to find my intercepts for this one. Our domain for this would be 0 is less than or equal to t is less than or equal to 4. What about the range? Well, it's the same idea. I'm looking at Q1. This time, though, what I'm considering is I'm considering the maximum value. And when do I hit the water? I mean, maybe I could call that a minimum, right? It's the minimum height that I have. Well, that would be my minimum height is 0, and my max height, we said, was 9. So when we start talking about domain and range on applications, you have to think about what makes sense for the question. GGG is a very important question for my diploma. How long is the rock above 8.5 meters? So what I'm going to do here is I'm going to draw in 8.5. Now 8.5 is roughly right about here. It's not perfect, but it's right about there. There's 8.5. So how long am I above? Well, that's this portion right here, isn't it? When I hit 8.5 for the first time and where I hit 8.5 for the second time. So the rock is above for this little arc here. So how do I find that? What I'm going to do is I'm going to find there's 2 points of intersections. So I'm going to subtract the x part of the intersections. I should call that the x-coordinate of the intersections, but that's okay. So all I'm going to do is I'm going to, of course, go second calc intersect. And then what I'm going to do is there's going to be 2 intersections. So I'm going to say the time above is, I'm going to take the furthest intersection, which I'll call x2, and I'll subtract the first intersection, which is called x1. Now, I'm not going to graph that. I'm just going to say it looks like this one here is at about, I'm just estimating, friends, 0.3 seconds. This one here looks like it's at, I don't know, 1.7 seconds. So how would I find this then? Time above would be 1.7 minus 0.3. It would be above for approximately 1.4 seconds. Of course, on a test, I'm going to find that answer properly. So again, just to reiterate, it's not always about just finding the numeric value. A lot of times on a test or a diploma, it's about where do I look, the characteristic. Okay, so just remember my wording that I've written here. I'm going to find the h coordinate. I'm going to find the positive t-intercept. Those are important terms. Okay, there it is, friends. See you next time.